Hello everyone, my name is Rami Aluta and I'm a Senior Solution Engineer at Azure. Today, I'm excited to share with you a rapid damage assessment workflow using imagery acquired after the February 2023 Turkey earthquake. This workflow will leverage the power of ArcGIS pre-trained models and Azure OpenAI services. By combining these technologies, we can efficiently classify building damage using AI-powered models, enhancing disaster response capabilities. With that, let's dive into the demo and explore how this workflow is implemented. We will start our journey from the ArcGIS Living Atlas by searching for the vision language context-based classification model. This is an AI-driven model that is designed to analyze images and classify objects based on both their visual and contextual characteristics. It plays a key role in our workflow, allowing us to assess structural damage from aerial imagery with enhanced accuracy. We will download the model in order to use it in our demo. Let's switch over to ArcGIS Pro and look at an example of a disaster-stricken area. The images in front of us shows the devastating impact of an earthquake, with the collapsed structures and debris scattered across the landscape. To begin our analysis, let's first examine the building feature class. This dataset consists of building footprints representing structures in the affected area before the disaster. As you can see, we have more than a dozen buildings outlined, but without any indication of their current condition. This is where AI-driven damage classification comes in. Next, we will navigate to the geoprocessing pane, expand image analyst, find deep learning, and then locate classify objects using deep learning. This tool allows us to apply pre-trained AI models to analyze and classify image-based features. Let's start filling in the parameters. For the image, I'll choose my input Turkey earthquake imagery. You notice I've got an error in here, which is really because I'm using an image service and it's on a large country scale, so I'd like to only process a small extent. I'll go and click on the extent for current extent, and then you'll see that this will disappear in a moment as I'll be processing maximum 5000 by 5000 pixels. Next, I'll need the features to classify, and for that I'll click on buildings. For the output classified objects, I'll just call these classified buildings. Then I'll navigate to the downloaded model definition. I will paste the downloaded DLPK path, change the class labeled fields to damage. This can stay as default if needed. For classes, I know I'm gonna be looking for 3 different classes. Therefore, I'm gonna bring these in, which are minor damage, major damage, and no damage. I'll drop these into my classes. For additional context, we really need to help the GPT model that we're going to use in understanding the context of the image that is looking at. Therefore, we're going to provide a description that says this is an aerial view of a building from an earthquake impacted area. I'll go and paste this in here and you can see the rest of the sentence. I'll keep the strict classification as false, and for the AI connection file, I'll provide a local JSON connection file to the Azure service. Let me edit the quotations in here. So this configuration file really contains the API key and an endpoint details for the Azure OpenAI servers, which powers this workflow. It's really essential to move forward with this workflow. Yet, if you don't have an OpenAI service, the same model supports Llama. Therefore, you can work with a locally downloaded open source large language model to perform the same workflow. As a last step, I want to navigate to environments and edit the cell size to 0.3, which is equivalent to 30 centimeters. That's the resolution I want to run the imagery on. Once ready, I'll hit run and wait for the classify objects using deep learning tool to be done. In the meantime, I'll switch off my video and fast forward through this, as the tool might take a minute or two to complete running. The tool finished running successfully. We will first examine the classification performed by the model. Let's check the attribute table of the classified buildings feature and look at the damage field. We can visually verify that the features were classified with major, minor, and no damage, and some are unknowns. We'll close the classified buildings attribute table. Next, to better interpret the results, we will import symbology from a pre-saved layer. We will navigate to Feature Layer, then from the drawing, click on Import, and navigate to the pre-configured symbology layer. I'll click OK, then I'll click OK. This applied the color-coded damage category and labels for quick visual analysis. We can examine the results in more details in the screen. Note, as we are using a GPT model for this workflow, the model isn't particularly trained on damage data. Therefore, a room of error might occur. We can see some here where this is unknown and unknown. Human in the loop is always necessary to verify and confirm deep learning driven results. Through this workflow, we've demonstrated how ArcGIS Pro and AI-powered classification models can be integrated for rapid damage assessment. By leveraging the Vision Language Context-Based Classification Model and Azure OpenAI service, we efficiently classified building damage using aerial imagery. This approach can significantly enhance disaster response and recovery efforts. Thank you for your time, and I look forward to any questions you may have.